Hi everyone. So this is the screencast for multiplayer CA3, which is making a multiplayer using a UDP based network system. So I'm just gonna quickly list out the things that I want to talk about in this screencast. So first thing first is gonna be the client overview. So that's gonna be explaining some of the base code that and then some of the stuff that I added in as well from the base code, and then after that the server overview. So same thing with client, but it's just on the server side. Um, I'm gonna talk about the compression, synchronization, and then game persistence. And lastly, I'm gonna talk about the bandwidth calculation and how many players can support on my network connection. So first thing first, let's get started with the client overview. So there's a lot of things on the client here. So the main things are in the RobotCat client and the Network Manager client. So the RobotCat client here is updating every time to process input, and then the simulate movement as well in the client side. So that way, player can send in, oh yeah, I want to move my player over here or there, and then try to simulate that. And then it's reading a lot of these bits from server. So basically, it's like um, this is really good so for another player as well for when they're moving and stuff like that, get their replication location and stuff like that. So the client able to get the synchronization from here. Now, obviously, a lot of this is just the base code. The only thing, um, the only thing that I customize it to in order to work like my game is the lobby state. So because we implemented lobby state, and then my part, the code that I am responsible with is residing on this network client and RoboCat client, and then later on I can go over in the RoboCat server when I disclose the server overview. So, and then we have this network manager client. This is how a client handle sending a packet from a client or is getting a processing a packet getting from server. So there's a lot of those, and then so there's a process packet here. It's reading in what the packet type is, and then there's a welcome CC. This is where when if we send a welcome and then the server accept that and then send back a welcome message. State CC, so this is where it always get sent every update, so the server can synchronize the client and the server state. Um, and these two here are customized, so I can explain that later on. Uh, this is then going set outgoing packets. So basically, we have different state. If the client on this different state, it will send this three different packets, and then the last one is my uh custom state. Now let me just explain the work that I added on the client side, especially for the lobby state that I'm responsible for. So as you can see here, so the let me just explain the basic idea of what the lobby state should do. So the lobby state itself should restrict player movement. So when players are entering the game, they are not able to move, they're not able to shoot. So that's the main thing in the lobby state. Now, they able to press enter to ready up, and then when you basically when the player are pressing enter, the network manager client here able to detect that and then send a packet to the client, send a ready packet to the client, and sorry, send ready packet to the server, and then the server later on able to uh, get that and then put that in a map and then see how many players are already ready. And then if the total player ready and the total player that is connected to the game is the same, then that means all of the players already ready, all players ready to play. And then when that happens, the server will send back a packet saying, okay, you can play the game now to all the client, and then uh, basically, uh, in the client that gets handled, and then lift out all of those restricting like the movement and shooting restriction, and then the player can play the game. Now to go a bit detail here, so we can go to the RoboCat client. In the process input there, just so just did the restriction for so if you can see there's M is ready to play and stuff like that. Which is basically the restriction for the process input for player not able to move. But that part is not my part. That is just part to implement. So he will explain that more detail in the screencast. Now, in my part here is just saying if M is entered and M is pressed once, which is basically if M is entered get changed when the enter button is pressed, that's become true. And then when it's true, it set the network manager client state into test. So if we go to that method, it's just saying into test with the naming. I admit the naming is not the best because this is when I'm experimenting, but basically the task state here would send a ready packet on the client. So this will call the function for send ready packet, and then that will send a packet type of kReadyCC and then send the player ID. So why sending the player ID? So we can in the server side we can put that ID into a map. So it's just a good way to track which one is ready or not. And then obviously so the server when every time the server sorry the server is receiving a player ready or a player connected and stuff like that, we need to update the total player in the game and then how many player are ready. This is strictly for the UI, so if I try to run this, I can show you and run. So this is strictly for that UI is a 0 out of 1 is ready player. So this is will get updated every time and it's 3 special occasions. So every time a client is connecting to a server, every time a client is press the ready button, and every time a client is disconnecting from the server. So those 3 special occasions will send a packet called kplayers count cc from the server, which is basically informing all the client what is the total player that will get displayed here, and then how many player are ready. So in this way, if someone already ready and then get disconnected, that will immediately update how many player in the ready because we can talk about how it handles the disconnection, but it's just to synchronize how many player are ready and stuff like that. This is very useful for the way the lobby state works because the lobby state, unlike the previous CA, this previous CA is basically okay, the master host just press enter and the game starts. So we know when to start. Whilst on this game, we kind of have to wait. Is everybody ready? Is someone did not ready? At least now we know the number, even though we don't strictly know who is ready or not. But at least we know the numbers. Like, oh yeah, there's one person that is not ready yet, or like there's 2 person that is not ready yet, which is quite helpful to know as a player. So stop the server, yeah. So on that kplayer count CC packet, it will read in the total player, and then it will read into the ready player, and then assign that variable into a variable existing on the network client. And then this will be basically displayed on the SF render manager. On the render UI, I have a ready count text, which is basically just setting, okay, I'm just getting number of the number of ready player, the number of total players, and then just print that on the screen. So that is kind of explaining the player count CC. Now, the K-start CC is the only packet you get when all of the players are ready. So every time, uh, excuse me, every time a server getting this packet, I said that is the calculation whether they calculate, okay, I put this player ID into the map and then now calculate is the player ready size is the same with the connected client into the server. If they're the same, the server will send a k-start cc packet, which is basically it's just a packet. It's just a packet that contains the packet type because when you get the packet type, you know that the game should start. So the server sends that to all the client, change that the state into game start. Now in the game start, you see there's nothing really happening here. We don't really have a thread step, but oh, sorry. But that gets handled in the RoboCat client. So basically, if the network state is 4, which is if I go to the group manager, 4 is the game start. I know this is not the best way to do it, but so if checking if the NCS the net state is game start, and then left all of the restriction, the boolean restriction into true, which is basically you can shoot now, you can simulate your movement, and then after that change the state into welcome, so you can process input in yeah, so update you can keep start sending update, sending input packet and stuff like that. So that is the overview on how the lobby state works. So there's two extra packet type that I created, and then I think around two network client state as well that I created just to suit how the lobby state works. And now we can go to the RoboCat server, which is the server side. Now the server side is working as the RoboCat server is the same as almost the same as the client, have the process input and simulate movement. So basically, with the client process input and the client simulate movement and then the server simulate movement has to be the same. If they have different so and then server is sending, okay, you should be here based on your input and stuff like that. And then if they are different, uh, the RoboCat client will get this two client. Well, it will try to run the uh, interpolate client side prediction, which is basically saying, okay, you're not where it's supposed to be, and then RoboBand to where the server says you should be. Now, obviously, there's much detail on that. But all of those are just based on the base code base. So I didn't do anything extra on that, but I did on the RoboCat server. The only thing I did for suit the lobby state is this piece of code here, which is when all the player ready lifted the restriction as well. So because RoboCat client and RoboCat server obviously are two different separate instances, and then we know that they all two has to be synced together. So with the rubber band effect that I talked previously, so if I don't release all of those restrictions on the server side as well, it will say in the server side your player are still stay in place. You don't shoot. You doesn't move around. So while in the client able to move for a couple of bit, and then when the server noticed that and server send in the bit of the location, the rotation and stuff like that, and then the client detect, oh, this is pair different, so just use the server and just rubber band immediately. So that's why I have to release that saying, okay, you're allowed to move now as well. The server should know that you are allowed to move as well, so it will begin to actually simulate the movement correctly and handling the shooting uh, correctly, if that makes sense. Now, that is the RoboCat server. So obviously we have network manager server, so similarly to the network manager client. So we have also a process packet, and then this is checking if the address from the client is already in the map, if the server know that address already. If it doesn't found it, basically, oh, this is the new client, and then if does found it, and then it's just okay, this is the existing client, and then I can start process all of this packet type. Now, the bit interesting here, so I also put the boolean restriction over here because why? Because if this is basically saying if I am not on the lobby state, do not handle any new client. So because the win condition for the game is to the last man standing. So I don't really want the game to be extended by just continuously joining the game. So like new player joining the game, new player joining the game. Thus like the game will never end. So because of the lobby state, you are allowed to join while the lobby state is going on, but if the game is already played, you're not allowed to join. So that's kind of I guess kind of improve the game loop in a sense. Like there's a two different state and stuff like that. So yeah, that's the kind of important bit there. In the process packet type, so once we handle, actually we can go to the new client first to see, okay, so this is how the code base handle a new client. So basically reading the packet type, create a new player ID, put that into a map for the player ID to client map, so that updates how many player that is connected to the client. And then send the welcome packet. So basically, I already able to get the welcome packet. This is a new client, and then I will send back, okay, hello client, and then that will get connected into the okay, welcome CC on the client side. But that is on the code base, on the base code, sorry. And then the bit that I added here is the notify player account. So this method is basically just sending the K player account CC. Remember, I mentioned that we need to we need to notify all of the client of the total player that is connected to the game and the total player that is already on the game when the client is a new client is connected to the server, a player hit a enter button or radio button, or sorry, and a player disconnected. So one of those instances are when the new player are handled. So basically, after sending the welcome, we pretty much sure that the new client is accepted, and then we notify all the connected the existing player the existing client that okay, I know I have this total amount of player connected to the game, and then I have this total amount of ready player in the server. Now, potentially in this specific case, I don't need to update the amount of player that is ready up because theoretically when a new person joining in the game, he will not able to ready up because there's no time for him to press the enter button. So I just need to update the total or the total player in the game. Now, but I didn't do that because that sacrificed code efficiency basically. So I can just reuse this method 3 times rather than creating a new line, a new one every time. But that is arguable with the size of the traffic. But it's just that at the time to save time and efficiency, so we can look on other things. I just settle on this one reusable code for all of those 3 cases. So that is handling new players, and then this is process packet when you already know that the player is on the game. So there's a hello CC, which is basically when the client sends a hello packet, you can process that and then send back the welcome packet if need to resend the welcome packet. The K input CC is to read all of the input, the handle input packet that is coming from the client, so in order to bring all of those inputs. Now, the ready CC is whenever a player press and enter. So when a client press and enter, it will send the ready CC, the ready CC packet here, and then that will get processed on the server, and then this basically what the server do is just go to this method, and then it says send and response test packet, but this is not always I would not always 100% send the response. So I only want to send the response um, when the player all players are ready. So we reading in the player ID, and then we put that player ID into we try to find the player ID first if a player is already ready up. So just an extra check. If not, then don't do anything. It's already ready up, so we don't need to process anything. Now, when it doesn't found, just put the client proxy into the M player ready map. Then immediately after assigning that value, just check the size of the M player ready size with the connector player size. So check if all players are ready. If not, just notify that there is someone ready up. So this will update the player ready. Now, similar to the previous case, we can argue you don't need to update the total player because the total player will not change when you just enter. So it's just press an enter button. So the only change here is just the end player ready size. But again, that would create a custom method again, and then it just yeah. And then, but in the case that and the player ready size and the connected player client on the map is the same, we can start writing the case.cc, which is basically yeah, you can start all the game now. So and then release the booleans, basically saying, okay, yeah, you are out of the lobby state in here, and then so that means I'm stop handling new client while I set this into true, and then this just send that k-start cc packet type into every client that is connected into the game. There's nothing really after that, because remember in the client you just need to you just know, oh yeah, I get this packet type, I don't need anything else, and just change the state into game start. No, connecting to that in the RoboCat server, so get all player ready. So basically just return the if am I out of the lobby state? If yes, then set all of those process input and simulate movement restriction to be true. So the server side can simulate all of this input and movement correctly in conjunction with the client. So that is the client and server overview. Oh, sorry. There's one main thing again. There's on the server.cpp where I had to change how the spawn point works. So basically, the spawn point before was just a factor 3. That is just listed down here. Now, because the nature of the lobby state, there's gonna be more instances of the same player are spawning in the same place if I don't do something about it. So for example, because it's dealt randomly, so I could get index 1, and then the next player can get index 1, and then the second player that gets index 1, while I'm still there, he will only able to see a black screen. So that is a spawning issue because the lobby state doesn't handle spawn point correctly. So basically, what I do here is to create a spawn point struct that will hold the factor 3 position and the player ID. So I can track, okay, spawn point index 1 is in this position, and the player ID, for example, if there is something there is player ID 6. So then I know, oh, if the player ID is not empty, then I can just go to the next to the next spawn point. So let's go back there. So here is where it's handled. Let's see, in the spawn cat folder. So every time it tries to spawn, it will loop forever until it's able to spawn a player. So basically, it will get try to random on the spawn point size. So that I set that into 13, if I remember correctly. 1, 2, 3, 4, 6, 7, 8, 9, or 15, I can't remember. But yeah, so whatever the size it is, and then get that the actual spawn point, and then check if the player ID on that spawn point is -1. So it sets -1 because the player ID will never go below 0. This is basically if that's a mine flag whether to check it's occupied or not. If it's occupied, then it's gonna be not -1. It's gonna be 0 from whatever the player ID is. But if it's a -1, then it's 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 free. You can use them. So that's why if it's a -1, you can set the cat's location in that position, and then assign that spawn point player ID to the player ID, and then get out of the loop. If this is not -1, it will keep looping forever, and then that is the case with if there is no spawn point free anymore, it will just looping forever, which is maybe not the best idea, but in the client side it will look like you're trying to connect to the game. So a better idea of this, instead of having a for loop forever, so basically because the random is maybe too random or something like that, and then I have, for example, a random number from 0 to 15, and then I know that number 2 is or is it occupied, and then for example, if I get number 2 and then it's right, okay, I do not hit this because I know number 2 player ID is not -1, and then it will go again. The chances if I get 2 again, or like something is unoccupied, sorry, something occupied again, is kind of high, to be honest, because like there's only 15 spawn points. So if you say like 7 is occupied, like there's only 6 that is unoccupied, and then it will try to get like the, how do I put this? The random index to hit unoccupied is will be lower and lower and lower. So like if you are the last player join in of the 15, it will take a while, because like there's a chance, oh, 1, oh, it's occupied, 2, oh, it's occupied, 3, it's occupied, oh, 1 again, it's occupied. So it will look like to him it's like gonna be a while while it's connecting to the game. So I had it on top of my mind that while maybe we need a factor or an array to store an available spot, available index. So uh, so that way, if for example, I'm starting with number no, it's just a factor storing an n, so like number from 0 to 15. And then every time it's get picked, I just delete the, for example, I get picked 7, index number 7. I just delete index number 7. Now, the random index should be just choosing the index of that available spots. So, for example, the first time around is going to be 0 to 15, so a random number. But then now 7 is come off. Now it's going to be 0 to 14. Now it will pick what index it is, get the value, for example, I get the index of 7, get the value of 7, for example, is like 8 because 7 is kind of off. 8 and then get 8 and then it will know immediately that it is empty, and then it will go spawning the player on that location. That potentially can reduce a lot of calculation time. There's nothing really. This is not a compression on network or something like that. It's just purely just calculation efficiency. It's just that yeah, I come up with this solution really late in the day. I wish if I had like a day or something to implement it and then test it whether it actually works or not, then that might be get implemented. But at least I just want to get it out that there's a plan here to improve the efficiency on picking the random spawn points. And then I also need to get rid of the player when they lost connection to the client. So basically, just get the player ID of that disconnected player. So using the for loop, and then send that spawn point and player ID into -1. So just tell that okay, it's unoccupied now, and then a new coming player can go into that spot. So yeah, that's basically the overview of client and server. There's a lot of that is the majority I feel of my work on the CA. Now we can talk about compression and game synchronization. But to be honest with you, all of the compression in the game is the same with the code, the base code that we have as a RoboCat and Shadow. Obviously, we can say a lot of these are because we are available with input bitstream, so we can say, for example, if I can get this on the screen, RoboCat client. Let's see here. For example, there's a lot of instances where I can just specify how many bit that I want to send. For example, health, because health is the maximum number, will not go more than 4 bits to represent it. So that way, I just only need to synchronize that every time is only 4 bits. I only need to sending it 4 bit, even though I'm storing it in maybe UIN8 because that is the smallest uh, storage access that I can find. But the majority of this compression on the base code is using the state bit or the state bit, which is basically like I can't remember what they call, but basically it will send bunch of booleans with the boolean, which is basically say has it changed from the previous state. So for example here, this is checking if the player ID has changed from a player. So if this is to be true, yes, then it will read the next bit as the player ID. If it's false, then you just entirely skip saying player IDs. And then the next one, the same with the velocity and rotation. If the players just stay in place, or the velocity and the location hasn't, velocity, location, and rotation hasn't changed, it will just read the state bit and then just move on to the next one. So every each of the parts, so I see it as like okay, a state bit, and then after that, the one that you want to check whether it has changed or not. So that is a player ID. The next one is a state bit, and then check if the location, rotation, and velocity, location, rotation has changed. And then state bit, this is like the thrust direction, or what direction it's moving around. And then if else, just set it into 0. And then the last one is the color, if the colors has changed. And then here, lastly, is the health. Has the health changed or not? So probably the most common here is gonna be on the location and rotation, and then maybe a little bit of health. So a lot of compression here. So this is gonna be just one. If on your normal daily basis, the most common is gonna be this is just gonna be one byte, and then nothing more than that, and then because this is just reading a boolean, and then one byte here, and then read all of this, which is basically I think this is 4 bytes, 4 bytes, 4 bytes, 4 bytes, and then this is a 4 byte of float. So that's 1, 2, 3, 4, 5. That's 20 bytes. So this is 1 byte, 1 byte for the state bit, 1 byte for the state bit here, and then 20 byte for the whole location if they do change. And then this is maybe get change as well, but if you change the direction. So this is reading in just a boolean, so 1 byte, so 2 bytes with extra state bit here, which is uh, sorry, 1 byte as well, so that's extra 3 bytes. And then this is health, which is you only get change when you get hit and something like that. So there's a lot of good compression here. I know that this is can be much more further improved. For example, like a player ID could be maybe lowered down to UN 16 if you're just expecting a 15 player and then send it based on like per bit. Um, yeah, that's correct. Yeah, and then maybe instead of sending a boolean, you can just send 1 bit or something like that. It's just that we are, to be honest with you, the only reason why we haven't really touched compression is just one, it takes time to understand the existing code base, and then it took time to actually improve the efficiency. We could have done that, but we decided to prioritize to create a more networking pieces like the lobby state and the player persistence for JAWS, and then the spawn point, etc. So that way we can show off we can change the packet and everything. But we are aware that a compression is something that is exists in the game that we need to address on, but it's just that simply we put a lower priority on it. And yeah, so basically that's all I can say for compression. It's a bit shame that we haven't really able to um, utilize this. For example, like even the simple things like the in the network server here, where the it notifies the player for in order to get synchronization on the. So this is very important. Like the notify. See if I can find it here. Disconnect and the client disconnected. Notify client. Yeah. So this is fairly not efficient. So this is this is important to synchronize the number on the ready UI for you to see like the how many players here and then like what time does it need to send packet and stuff. It's very important, but this is going to be furthermore improve. Obviously, the one that I talk about, I doesn't really need to. The only time I need to send all of those two information together is just when a player is already ready and his disconnected. So that's why I have to update the player ready and the player connected ID, which is that is kind of I wouldn't say a rare situation, but it's basically not 100% the case of the time. So I could reduce that by 50%, the size of it, and then obviously with the amount of the player size and stuff like that, it doesn't have to be a full N for bytes. I could just send in a UN 16, 16 to represent those the size of the map. Eventually, considering when I send that into all the client. So yeah, so compression, to be honest, it's something that we kind of look over. And then I think I can talk about it, but it's the fact that I haven't implemented it never changed. So I just want to admit that there's work need to be done for the compression. Or at least we are able to notice where the weaknesses of the compression, or like where what part is need more compression, and then have a plan on how to do it. So that's for my part. And then game synchronization as well, because we don't it doesn't really change the premises of the game. We still, because the Shadow game or the RoboCat game rather is just able to shoot, move, and collect some pickups. We haven't really changed the premises. The pickups still pickups implement health. The shoot we changed the direction of the shoot, but I only did some debugging on that. So basically using the process. Let me see if I can get the input manager. Yeah. So here you can see there's a Q and E, so basically changing the boolean of shooting and shooting right and shooting left, and then the shooting right and shooting left is get thing across the network with write and read, just like any other variable that I wanted to thing across the network. But basically, it's just telling the direction. If it's shooting left, then I just change the rotation of the arrow, and then if shooting left, the same thing. It's just that I cannot talk this in detail because Josh did almost like 80% of it, 80% of the feature. And all I did was we had some trouble on why the arrow is not synchronized from the server, or it's just like all of the booleans here is just saying true for no reason. It's just the fact that I forgot to add this synchronization into the client and server, so that's why it's not been synchronized. The server still see, yeah, all of this is true, while the client is still able to see, oh yeah, the false and true. So that's why they are not synced. Uh, but that's only my part on the shooting direction feature. And then the major game state synchronization custom that we can arguably customize is on the ready player zero out of ready player out of the total connection. So that has to be synchronized because if it's not synchronized, people will see different numbers and stuff like that. And basically, the way we synchronize them are using are sending packets every time the client are connected to the game, hit the ready up button, and disconnected to the game. So that's how. And then the packets that I'm sending is always the same. The same every time. It's just the total total player connected to client and then total player ready. So that is all I can say for the player synchronization. Everything else is the same with the base code game, unfortunately. Now the game persistence. The game persistence here, we have the original code base using the sprite manager for the players. So let's see if I can find it here. Get player ID. Get player ID. Is it here? No. Game started. No. Find path help. So we just need to render textual render component. Oh no. Okay. Okay. There you go. Sorry. Player persistent sprite. So uh. Well, we have this is the same with the code base. So basically, it's just calculating with the player ID, where player ID will always get the same player ID once with the limited posts in here, and then it's just adding the player entry in the save persistent.txt. I can show you here. Uh, save persistent texture, and then you can see the name. Oh, sorry, the name of the player, the ID, and the ID, and then it's just reading of that, and then texture manager. Uh, sorry, not texture manager. Let's see, where's that? Player texture generator. It's getting the player texture ID to Roman and Frigate. So Roman, basically, if you get the player like 0 or 1 0, and then if the Frigate is like 1. So every time like you get modulus by something, and then the result is 0, you get a Roman texture, and then if the result is 1, then you get a Frigate texture. So that's how we kind of we don't really refactor the player system. It's just that we kind of change this texture ID to our own ship, and that's it. The main game persistent is on the win-lose average scoreboard. So there's a in the render, the SF render manager. Um, there's an update win rate here. So basically checking if every time a player win, which is here, or a player lose, it added the score, true or false, and then it will update the win rate. So if you update win rate false, that means you have lost, and then if you update win rate true, that means you win. So all of this win lose average feature are developed by Josh. So I will give him the credit 100% here, and then um, I'm just gonna talk a little bit based on my understanding on how it works. So basically, this bull here passing in if you actually win or actually lose, and then you just incremented the win or lose based on the existing file in the save file. So I can show you the file base here. So the code just reading in there first. First of all, assign that into win variable, lose variable, and the average variable, and then basically based on the boolean, added up the score. For example, if you win, then just add it up from 0 to 1, and then if you lose, it's added up from 2 to 1 or something like that, based on whatever the line the persistence on the file, and then calculate the average, which is basically the win plus the total game you play, which you can calculate by the total win or lose, and then times by 100 to get the percentage, and then close the file and write that out into the same file. Uh, and that's basically how we manage the game position on the win-lose average. Um, we talk about on how we're gonna display it when you die or we play a win, but it does require times, and then we had some troubles on debugging the arrow direction, so that's why we end up not implementing it in the game. Now, lastly, I'm just going to talk about. It's been a long, a long screencast, but lastly, just going to talk about the bandwidth calculation. So, uh, so my upload speed, if I can get the here. So my upload speed is 205.23. So I just take that 205 Mbps, and then so I took that calculation in the upload speed, and then the bytes per player is 43.5 bytes. I'll get this number is from RoboGet client, so I'll calculate if all of the state bit turns out to be 2, so which is that translate into the maximum, the biggest amount of data that you have to reading in to replicate the RoboCat client, and then that is totaling to 43.5. So 1 byte here, another other byte here, and then like 4 bytes, 4 bytes. Sorry, that was 4 bytes. 4 bytes, 4 byte there, 4 bytes, and then so on. And then this is the color here, a factor 3. So factor 3 is 12 bytes because 3 floats. And then this one here is just 4 bits, which is half of a byte. So that's why, hence the number of 0.5 there in the calculation. And then the object per second is 20 tick rate. And then because we are calculating in bytes, we want it into bits, just times into 8. And then basically change the Mbps into bits. Does that give me 205 with 06 as 6 zeros flying it? And then in order to get the n squared, I need to divide it divided the Mbps with the 66960, and then that will get me the n square, and then to get the amount of players that I can connect with, just root that number in into, I get 171.62, which is translate into, rounded it down into 171 players. So yeah, that is the bandwidth calculation. That is the whole screencast. I know it's a bit long, and then the whole project, I feel there's a lot of more could be done, especially I've been neglecting this comes to synchronization and the compression, and then there's definitely should been a lot more uh, like a game state kind of customization and like how the game plays, because basically the games right now is just like kind of reject of Shadow. Like they still doing the same, but I think we are kind of right on focusing on the lobby state and then the game persistence with the scoreboard because that is something new, something unique from the original base game, and then that kind of demonstrate how our understanding with the client and server, sending packets over the network using UDP. So I think that's it. That's it for the screencast. I hope this has been clear and useful. Thank you very much.